Every day, an entire web of observatories watches the sun, measuring brightening, fading, and the tiniest magnetic stutters. We built our world assuming that this light is unbroken, predictable, unshakable. Power grids, satellites, weather systems, all depend on a star that behaves like a metronome, and for decades that trust has held. The sun has been steady to the point of boredom. But then imagine, just once, that stability snaps for a heartbeat. Not minutes, not even seconds. A single abrupt drop. Inside the sun, something shifts. A sudden global decrease in brightness, lasting roughly 1 second. We'd notice nothing at first. Sunlight takes 8 minutes to reach us. 8 minutes later, every shadow softens. A brief, eerie dimming that feels wrong. Satellites see the day side drop by a third, then snap back instantly. Solar monitors catch a sharp notch, like a finger scraped across the sun's brightness curve. A few people might sense it, a strange shift in daylight. But instruments? Instruments don't sense. They confirm. Within seconds, solar telescopes flag the event, an unmistakable deviation in the sun's output. White light falls off cleanly. Ultraviolet drops slightly longer. X-rays take the longest to return to normal. Data from Parker's solar probe and helioseismic detectors are checked line by line, searching for any pulse inside the star. Across multiple continents, atomic clocks compare timestamps. The dimming arrives at exactly the time sunlight should. Except, one telescope high in the Andes reports something impossible. The dimming appears 2.17 seconds early. That shouldn't happen. Not through vacuum. Not through physics, we understand. Impossible, because sunlight cannot arrive faster. Not through space. Not through any known physics. At that same moment, a deep neutrino detector logs a small spike, not a drop, exactly matching the sun's flicker. Visible light, X-rays, neutrinos, but one of them is early. The pattern is consistent and deeply wrong. Was it a timing glitch? A calibration drift? Or did the sun send out something ahead of the photons we saw? To explain the flicker, scientists begin investigating the deepest layers of solar physics. A rapid coronal implosion could momentarily cool part of the sun's outer layers, enough to shave off a fraction of a percent of total brightness. A burst of exotic particles, axions or dark matter streams, could tweak photon transport inside the sun, causing a sharp 1-second drop. A brief gravitational ripple could compress solar plasma for a moment, altering its output before everything snaps back. Or a helioseismic shockwave, a deep, violent pulse, could momentarily disrupt the photosphere from within. Neutrinos already reach Earth before photons. They escape the sun instantly. But an extra 2-second lead? That breaks our current understanding. 1 second isn't world-ending. Civilization would barely notice. Most systems would log it as an anomaly and continue. But every archive would reopen. Every neutrino run rechecked, searching for a flicker we might have missed. Most people would shrug it off. A strange headline, a viral clip, a brief meme. But for scientists, the feeling would linger. For 1 second, the sun hinted at something our equations aren't ready for. If the sun ever blinks again, and something arrives early, would we call it an error? Or the first hint that our star still hides surprises from us? Stay curious. The next blink might be closer than we think.